Hello everyone. Hello everyone. This is Yashwant Putta from CSC AML D section. Today we are going to discuss about working with C++. Welcome to the world of C++. Whether you are a beginner or an experienced programmer, this presentation will guide you through the key concepts and best practices of C++ development. Debugging tips in C++. Debugging is an essential part of C++ development. In this slide, we will explore some helpful tips and techniques to quickly identify and fix bugs in your code. From using breakpoints to analyzing stack traces, you will learn practical strategies to enhance your debugging skills. Daily examples: finding the largest number in an array, implementing a linked list data structure, sorting an array using bubble sort algorithm. Use count or printf statement to print variable values and messages at different points in your code. This can help you identify where the issue might be. Most integrated development environments have built-in debuggers. Set breakpoints in your code and step through it to see the values of variables at each step. Review your code logic, make sure that your program is following the expected flow and that conditions are being met as intended. Assertions in your code to check assumptions about your program. If an assertion fails, it will terminate the program and provide information about the failure. Memory debugging tools. Utilize tools like Valgrind or Address Sanitizer to detect memory related issues such as memory leaks or out of bounds access. Employ static analysis tools like Clang Static Analyzer or PVS Studio to identify potential issues in your code without running it. Implement logging in your application. Write message to a log file that can help you trace the program's execution and identify where error occurs. Enable compile warnings to catch potential issues during compilation. If you have a large code base, try to isolate the problem. Comment our out sections of code or create a minimal example that reproduces the issue. Have colleagues or peers review your code. Fresh eyes might catch issues that you have overlooked. Introduction to object-oriented programming in C++. In this slide, we will dive into the fundamentals of object-oriented programming using C++. Discover how to create classes, objects, and methods to organize your code and build modular and reusable programs. Learn out encapsulation, inheritance, and polymorphism. Key concepts in OOP. A class is a blueprint or template that defines the priorities and behaviors common to all objects of a certain type. An object is an instance of a class. It represents a specific entity and interact with other objects. Encapsulation. Encapsulation involves bundling the data and methods that operate on the data into a single unit. This helps in hiding the internal details of an object and exposing only when it is necessary. Abstraction is the process of simplifying complex systems by modeling classes based on the essential properties and behaviors they share. It allows you to focus on what an object does rather than how it achieves the functionality. Inheritance allows a class to inherit its properties and behaviors from another class. This promotes code reusability and establish a relationship between classes. Polymorphism. Polymorphism enables objects of different types to be treated as objects of a common type. It includes compile time and runtime polymorphism. Virtual functions allow methods to be overridden in derived classes. A constructor is a special member function that gets called when an object is created. It initializes the object state. A destructor is a special member function called when an object goes out of scope. It is used for releasing resources and cleaning up. Introduction to C++, powerful language. C++ is a higher performance general purpose programming language that offers low level control and high level abstractions, making it suitable for various domains, wide range of applications. From game development to system programming, C++ is used to build software that requires efficiency, speed, and close control over hardware resources. Foundation for many other languages. Understanding C++ provides a strong foundation for learning other programming languages such as C hash, Java, and Python. Basic syntax and data types. Clean and structured code. C++ syntax allows you to write clean and structured code, enabling easier maintenance and collaboration. Data types for all needs. C++ supports a wide range of data types, including integers, floating point numbers, characters, strings, and more, providing flexibility in programming. With powerful operators like arithmetic, logical, and bitwise, you can perform complex calculations and manipulate data effectively. An instance of a class, a blueprint for creating objects, defining attributes and methods. Attribute data members that characterize the object. Method functions defined within a class to perform operations on class attributes. Inheritance mechanism for a new class to inherit properties and methods of an existing class. Encapsulation bundling of data and methods that can operate on the data within a single unit. Polymorphism ability of a method to do different things based on the object it acts upon. Control structures and functions. Explore decision making constructs like if else statement, switch cases, and loops, enabling program flow, control, and flexibility. Learn how to create modular and reusable code blocks using functions, promoting code, reuse, and maintainability. Discover over techniques to gracefully handle exceptional situations, ensuring the stability of your program. Classes and objects. Learn how to define classes and create objects to encapsulate data and behavior, promoting code organization and reusability. Inheritance and polymorphism. Explore inheritance and polymorphism concepts to create class and achieve flexibility in designing and implementing solutions. Abstraction and encapsulation. Discover the power of abstraction and encapsulation to hide implementation details and create more robust and maintainable code. Memory management, dynamic memory allocation. Learn how to allocate and delocate memory dynamically, enabling you to manage limited resources efficiently. Discover techniques to avoid commonly memory leaks and effectively manage memory, reducing bugs and improving performances. Explore smart pointers of features introduced in modern C++ to automate memory management and eliminate manual memory deallocation. Local variables are stored on the stack. Memory is automatically allotted and deallocated. Limited in size and scope is usually within a function. Dynamic memory allocation is done on the heap, requires manual allocation and deallocation. Using new and delete or preferably smart pointers like automate memory management. It's crucial to avoid memory leaks and dangling pointers. Smart pointers and RL principles can help mitigate these issues. Additionally, C++ introduced features like move cinematics to efficiently transfer ownership of resources, reducing the need of deep copying. Debugging techniques. Using a debugger. Master the art of using a debugger to identify and resolve errors, ensuring smooth execution and improving code quality. Logging and error handling. Discover techniques to log helpful information and handle errors effectively, enhancing the debugging process. Testing and test-driven development. Learn how to create comprehensive test process and adopt test-driven development practices to catch bugs early and ensure code reliability. Inserting count or printf statements in your code to print variable values at different points can help identify where the problem occurs. Incorporate the assert macro to check conditions that should always be true. If the condition is false, the program will terminate and print an error message. Utilizing a debugger like GDB or Integrated Development Environment debuggers, Visual Studio Debugger, set breakpoints, inspect variable values, and step through codes to identify issues. Tools like CPP check or Clang Static Analyzer can help find potential issues in your code without running it. Tools like Valgrind can help identify memory related issues such as memory leaks, invalid memory access, etc. Best practices for working with C++. Code organization. Follow best practices for organizing source code, files, namespaces, and directory structures, ensuring clarity and ease of maintenance. Optimize memory usage by allocating what is necessary and releasing roses promptly, resulting in efficient and reliable programs. Adopt good documentation practices to improve and code readability and make it easier for others to understand and contribute to their programs. Thank you.